um, is measured in degrees and will give you an indication of how severe this knock sensor believes the knock to be based on the harmonics that it's recording. Um, so if the knock sensor happens to think that this knock is very severe, it's going to put a significant value into this knock sum, something 3 or greater. Typically, if you see a 1 or a 2, it doesn't necessarily mean that you have a problem with your tune or that you have a problem with your car. Those can oftentimes just be basic engine noise, road noise. If you have a lot of mods done to the car, there's a lot of different things that can cause knock, downpipe rattling. Um, but in most cases, knock is real, so don't be quick to attribute it to false knock, especially when it comes in long strings like we have here, where the knock started and persisted. This is most definitely real knock, and it's not too bad, but it's definitely something we want to address because it's not good for the car to be consistently knocking, of levels 3 or higher. So that's the first thing that you can look at to try to determine how healthy your tune is. Even from the factory, don't be surprised if you're logging some counts of knock, because there are times when Mitsubishi's tune just isn't appropriate. It's definitely good to log your car, even if it's stock, and see the condition that your Evo is in as far as knock is concerned. Now I also have an external wideband hooked up. I have an Innovate LC1 wideband, and I'm logging that through EvoScan as well as another very useful thing to log. And if you don't have a wideband, I would strongly suggest that you pick up one and try to pick up one that's compatible with EvoScan so that you can log it side by side and be able to look at the data together. So having the wideband will give you the specific air-fuel ratio measured in the exhaust after the turbo, so you can get an accurate idea of how much fuel is being mixed in the engine, and if you need to add or remove fuel based on that. So it looks like in this case, throughout most of this run, air fuel was in the vicinity of 11.5 or so, starting out a little bit leaner and getting a little bit richer as we go, which in general, as a general tuning practice, is pretty much a good target. You kind of want to shoot for the 11.5 range, with maybe a little bit leaner than that in the earlier RPM band and a little bit richer than that in the tail end of the RPM band. So it looks like air fuel in this particular log is pretty good. Looking at timing, generally what you'll find is in most cars, the timing curve, as they call it, is going to start from a relatively low value at peak torque, and it'll ramp up as RPM goes up, as volumetric efficiency increases, as your engine's consuming more air more quickly. You'll add timing to compensate. So you'll notice that starting from the beginning of this pull, running maybe 4 or 5 degrees of timing, and as we progress, it's slowly going up to the point where at redline we're running about 11 degrees. So that's not uncommon. There is no dead set way to tune timing. Every car will vary. The same thing's true for wideband, although it's a lot more common to see similar wideband air-fuel ratios. As far as timing, it could be all over the place